Let's say we have a bunch of raw spaghettis and we want to find the longest one. So to translate this into a mathematical word, we probably have some array of lengths of these spaghettis. So I don't know, the first one is 33 centimeters and then 34 and something like this. And we're actually finding the maximum of this array. And up until now, people believe that this can be done faster than O of n. But I have a new algorithm that can do this a lot quicker. And it goes like this. First, we can stack up the spaghettis on table. So this is our table, and we stack up the spaghettis here. This is our hand doing it. And we cover the spaghettis with a flat surface, like this. This is our other hand. And then we remove our hand, and we realize that all the spaghettis fell on the ground except one, and the one left standing is the longest one. And since this algorithm does not depend on the number of spaghettis, it is done in O of 1. And if you check out, if you watch my last video I did, you'll realize that all this is just a logical consequence of what I did in the previous video. Now the only problem is with the proof that this one, the one left standing, is really the longest, since I did it by using a contradiction. But I think there is also a constructive proof, and you can do this at home, or I will leave this like for other scientists. Okay, so from now on, whenever you see an array of numbers, you can always think of it as an array of the lengths of the spaghettis, and then using all this you can get maximum in O of 1.